Corinne wants to advertise how many chocolate chips are in a big chip cookie at her bakery. She randomly selects a sample of 75 cookies. You can see that is the sample size. Selected a sample of 75 cookies and finds that the number of chocolate chips per cookie in a sample has a mean of 16.5. So the mean of the sample is 16.5. So that is the sample mean. And the standard deviation of the sample is 3.4. And a standard deviation of 3.4. What is 90% confidence interval? So we are constructing a 90% confidence interval for the number of chocolate chips per cookie for a big chip cookies. Okay, so let's write down what is given first. So here, the first thing we have is the sample size n equal to 75. So let's write that down, n equal to 75. They have given the sample mean. Sample mean is 16.5. 16.5. They have also given the sample standard deviation. Here is that 3.4. 3.4. And they have given the confidence interval of 90%, meaning of that is C equal to 0.90. That is the 90%. So you can see here, we don't have the population standard deviation. Sigma is not given. So if sigma is not given, then you can say that the sampling distribution follows the t distribution, not the z distribution. So let's write that. Okay, since population standard deviation is not known, the sampling distribution follows t distribution with n minus 1 degrees of freedom. So if I draw the sampling distribution here, along the x-axis, I will have the t value, and this is the t distribution. This is t distribution with n minus 1. Our n is 75. So 75 minus 1 is 74 degrees of freedom. So that is given to you. And we are looking for the 90% confidence interval. So in the middle, the area is 90%. So if you draw the area in the middle of the distribution, this area in the middle is 90%. If we label this, this is the 90% area. This is 0.90, 90%. Now the remaining 10% is divided into two tail. So meaning of that is on each tail, you have the 5% area. Let's label that too. So this area here is the 5% area, 0.05. And here, this area is also 5% or 0.05. And this value here is T sub C and negative T sub C. Now, what we need to do is we need to find this T sub C because we'll be using that. So let's find T sub C using TI-84 calculator. So if you want to find T sub C is equal to inverse T. That is in your TI-84 calculator, you have to go to second verse and number 4. Inverse T, area to the left of T sub C. You can see this is 90% area and this is 5%. So 90 plus 5 is 95% or 0.95. 0.95, or in other words, 0.90 plus 0.05, which is 0.95. That is the area to the left of T sub C. And then you need the degrees of freedom, which is 74. 74. Now we have to use our TI-84 calculator. So if we go to second verse number 4 and put these two values and execute the calculation, you should get the value of T sub C, which should be 1.6657. Make sure you do that in your calculator. Now here we are looking for the confidence interval. If you remember the concept in confidence interval, we'll have the point estimate in the middle. In this case, we are talking about the mean. So that will be the mean in the middle. That is sample mean. And then we add the margin of error. So it will be X bar plus margin of error. And then we subtract on the other side. So it will be X bar minus the margin of error. By doing that, with 90% confidence, we can say that the true mean lies in this range. So the true mean lies in this range. That is what we want to do. We want to get this interval, and we want to confirm with 90% confidence that the true mean lies here. So I need the point estimate and I need the margin of error. So we are going to find those two values now. So first is the point estimate. Point estimate. In this case, the point estimate is the sample mean, which is equal to, it's already given in the problem. Sample mean is 16.5. So 16.5. That is your point estimate, which is here in the middle. Now I need the margin of error. The second thing is the margin of error. Let's do that. Margin of error, we write ME is equal to, for the t distribution, the formula is t critical multiplied to sample standard deviation divided by square root of n. So let's plug in this value. T sub c we got here, which is 1.6657 multiplied to S is the sample standard deviation, which is 3.4, divided by the square root of n. Our n is 75. That is equal to, now we are going to simplify this using calculator. And after simplification, you must get 0.6540. So once we have the point estimate and margin of error, now all we have to do is we have to subtract the margin of error from the point estimate and add the margin of error from the point estimate to get the interval. So let's do that. So this implies mean minus the margin of error to get the left boundary for the interval. Your mean is 16.5 minus the margin of error is 0.6540. So if we perform this calculation, we should get 15.8460. So that is the left boundary of the interval. Now for the right boundary, we have to add the margin of error. So it will be X bar plus the margin of error, which is 16.5 plus 0.6540. So if we add that, you should get 17.1540. So we got the interval. So meaning of that is your true mean, with 90% confidence, we say that the true mean lies between 15.8460 and 17.1540. So that will be our conclusion. Let's write that down. So one more time, with 90% confidence, we say that the true mean lies between 15.8460 and 17.1540.